So we start today the exponent rules, okay? And like I said, this is rules you would have seen in 7th grade math, you would have seen in 8th grade math. I know because I taught both of them. And I taught this. So if you were paying attention, you would have gotten it in your 7th grade and 8th grade math. Now, some people don't like math, so they don't pay attention to math, but so we are rewriting, we're using exponent rules, okay? So exponents allow you to write multiplication problems in a simpler way. Some exponent expressions can be simplified, some cannot. So we're going to complete this table by doing expanded form for each expression, then rewrite into the new simplest form. So they did the first one for us. That 5 to the 2nd power really means 5 times 5, right? We all agree with that? 5 to the 2nd power is 5 times 5. 5 to the 5th power is 5 of them. 5 times 5 times 5 times 5 times 5, right? So these parentheses mean the same thing as each individual. Yes? We're okay with that? So if I were to count all the 5s I have there, I have 7. So I could rewrite it simpler by saying 5 to the 7th power, because both bases are the same. Both bases are the same. They're both 5 to those. Okay. So who wants to venture and tell me how I should expand this one? What should the first parentheses be to match with the 2 to the 2nd power? Yeah, 2. And we're going to use our, I would prefer to use the dot. Do they have the dot available? No. I hate using X because that's a variable. Can we use, oh, I know, above the 8 is that little star thing. We're going to use that instead. Oh, look, it just makes it a dot. Okay, so that's our first one. So we're not going to use the X, okay, the X, because we don't want to confuse it with variables, right? We just want to stick with numbers. So remember, the shift 8 is the dot. Okay, so that was the first one. Now, what are we going to make the second one? How would we rewrite the second one? Yep, 2, shift 8, 2, shift 8, 2, shift 8, 2, close it. Okay, so once we spread them all out, we can see how many total there are, right? How many total are there? If we count, how many 2s are there? Remember, to get the exponents, it's shift 6. There's 6 of them, so this is 2 to the 6th power. Okay, don't forget, shift 6 gets you that exponent. All right, anybody confused? Who wants to give me the next one? First set, that 3 to the 7, how could we rewrite that? The 3 to the 7th, how can we rewrite that? Remember, for the dot, it's the shift 8. Oh, yep. So yes, we would be going 7 of them. 3, 2, 3, 4, 5, 6, 7. I think I'm going to have to 1, 2, 3, 4, 5, 6, 7. I might have to go ahead and make a smaller font. Maybe not. What's the next one going to say? Yep, 3 times 3. So remember, we're getting the dot because that's the shift 8. Yeah, I'm going to make this smaller font. I'll go down to a 12. No biggie. Beauty of Cami, right? We can shift anytime we want. Okay, How are we going to say the simplified version? Yep, because if I count, there were 7 and then there were another 2. That's not. Okay, so 3, shift 6 to the 9th. Are we all okay? Does anybody need clarification? Or are we good? Okay. Tell me this one. Okay, the simplified expression form, count. There's 1, 2 2s there, and then 1, 2, 3, 4 there. So that's why it's a 6th power. Because they were all 2s and there's 6 of them. Okay, so that's all we're doing is that's why we're spreading them out so we can count how many we have. That how many we have when we count is our exponent on our simplified form. Okay, so who wants to give me this one? Does it change the rules just because it's letters and not numbers? No, doesn't change the rules. So what would my parentheses say? Yep, parentheses, X, shift 8, X, shift 8, X. Remember, that's where we get our dot from. And then we do another dot because we're doing, that was the dot between these two. And then what's the next parenthesis say? What's our next parenthesis say? Because I have an X to the 5th now. What is that going to look like? Yep. Make sure you do a parentheses because each X, it's an expression that we're separating. So I need 5 of them, right? Because that's up to the 5th would be 5 of them. Count how many X's we have. That's going to be our exponent. X to the 8. Ooh, Lily, how did you make the exponent happen in the chat? Okay, darn it. I wish it was something that we could all do. All right, so now we come to a tricky one. I'm gonna work this out with you. Be prepared. Notice that this X has a 3. That means we spread the X out 3 times. And the Y has a 2. So we spread the Y out 2 times. And they're gonna go in one parenthesis. So the first parenthesis is gonna go, parentheses, X. There were 3 of them. Times a Y, there are 2 of them. Okay, that's what we do when we have both variables. All right, we just spread them out like that. So what do we think the next parentheses is going to look like? What do we think the next? No, X's go with X's, Y's go with Y's. How many X's do you see in that second piece? Just one. Just one. How many Y's do we see? Two of them. So each has their own exponent, each reacts differently. But the way we get the simplified is the same way. We count how many X's and they get that exponent. We count how many Y's and they'll get that exponent. So for our exponent, what is that one going to be? How many X's do we have? Count how many X's you see? 4. And then how many Y's do we see? 4 as well. Oops, not back 4. Remember, we get the exponent with shift 6. Okay, X to the 4th, Y to the 4th. Just because they came to be the same exponent number doesn't mean that's always going to happen. Okay, we have to look to see. Okay, so each one of these pieces gets spread out separately, but we are going to go ahead and end up, when we do the simplified, pull the same parts together, just like we did with the letter one. So what am I going to say my first parentheses is? Yes, 7. Now, 2 7s. I only see 2 7s there. 7 times 7. 7 to the second power is all I see. So each parenthesis is just what you see in that expression. 7, 7. Then we have to do the X's. Do the X's. The first X. So this X to the third, how am I going to do that? How are we going to do X to the third? X times X times X, yes. Then we have to do the next piece, which is the 7. There's only one of them. And the next piece, X squared. What are we going to do? Yes, X times X. Oops. No C's, just X's. Okay, now for each type we count. So what do the 7s say? Count how many 7s you see. That's going to be his exponent. 7 to the, how many 7s do we see? No. Count how many 7s we see in this whole row. 3. Yes, because I see 1, 2, 3 of them. Same thing for the X's, okay? X to the, make sure you arrow off of the 3 for the 7. What are we going to say for that? There are 5 x's. Yep. Remember, to get to the exponent, it's shift 6, and to get the dot, it's shift 8. Okay. All right. So now we got to spread the stuff out. Okay, I see 1, 2. He's easy. How about those x's? What are we going to spread those out to be? Okay, how are we going to spread that out? I see a 4th power, so I only should see 4 x's, right? I think we got a typo there. And then I see a times 3, but there's only one of them, so that's all I'm doing. Okay. And then I have to spread out the last piece. How's that last piece going to be? Yes. X and then 2 y's. Yeah. X times y times y. Okay, so now we go do the math. This says 2 times 3. What's that? What is 2 times 3? 6. Because there's only 1, 2, and there's only 1, 3, we do the multiplication. It's not like these that have these big exponents on them. Okay, we can figure out 2 times 3. Okay, and then we count. How many x's are there? 5 of them. And an arrow. How many y's are there? 2 of them. Okay, so the reason why we did the 2 times the 3 is because there was only 1, 2, and there was only 1, 3, and there was no exponent involved. So we do that math, okay? As opposed to, this is 7 to the 3rd power. Could I use a calculator to figure it out? Yes, but I don't need to at this moment, okay? I don't need to at this moment. But since 2 times 3, there's just one of each, we do the math for that. Does that make sense? Okay, so let's go to the next one. Now we have to answer some questions because we filled out the table. Now we are answering questions about the table. Okay, first question. Work with your team to compare the bases and exponents of the original form to the base and the exponent of the simplified form. Write a statement to describe the relationship. So this is what we're talking about. Our original form, 5 to the 2nd power, 5 to the 5th power. Our simplified form, 5 to the 7th power. How do we see a connection? What did we see happen? I know we spread them out so we could see it, but what do we notice actually happened? What would have been a shortcut that we noticed started happening? Some people probably saw it. What pattern did we see happening? Same base, 5 with 5 with 5, yes. 2 with 2 with 2. Those are called bases, not variables. Okay, same base. But how did it change from, so they had the same base, but what happened with the exponents? What do we know? Look at the pattern. See if you could see a pattern on what happened with the exponents every single time. They got added together. Yeah, because when you spreaded it out, you were able to see, oh, there's really 7 of them. Okay. Oh, there's really, 9 of them. Oh, there's really, okay. So sentence answer. The bases of the original and simplified form are the same. And to get the simplified exponent, you add the original exponents. Right? Isn't that what we said we did? Is that what we said? Do we agree with that? Original. I forgot an I in this guy. Right? So these make these so much easier. Now we know, oh, we're allowed to just, as long as the bases are the same. So it's 5 to the something times 5 to the something. Those have to be the same bases. We can add their exponents when they're multiplying. Kind of cool. Okay, let's go look at the next one. Visualize. How would you expand 20 to the 12th and 51, 20 to the 51st? That would be this big expansion mess, right? That would be a huge expansion mess. But we know a trick. We know a trick. What are we going to do instead of expanding it out and having to have all these parentheses and stuff? What did we just say we could go do? What did we say we could just, what did we just say we could go do instead of having to spread them out and count? Add up the exponents. Okay, so let's go do that. Let's show that. So I am going to go do add the exponent form. Okay, we have a 20, that's my base, right? Let's make him larger though. If I can, stop arguing with me. And we're going to take 20 to the 12 plus 51, right? So what would we get? 12 to the what? 63. 20 to the 63. Sorry, I kept saying 12, but I wrote 20. Okay. So now we have to describe our reasoning. Okay. First, how would you visualize this? The simplest form. This is the writing one. The simplest. No, the simplified form of. Now, this is where we get around having words and math. We go ahead and do the math, like we stick it in the middle. 20 to the 12 times 20 to the 51. That's a level 16. What's this one at? He's at 14. So we got to make him a 14 as well. Watch the magic. And then we line it up right here. And we go back to this one, and after the F, we hit the space bar. Would be, we want this guy, right? But we want it in 14. Where'd you go? And we're going to slide him in there. Why do we know it's 20 to the 63? What did we do? Explain our reasoning. I got to move that 20 to the 63 over, so I forgot the word B. What did we do? Because we know we can add the exponents when the bases are the same and we are multiplying. Okay, the bases have to be the same. So it has to be these were both 22ths, right? These were both 5 2ths, 2 2ths. They have to be the same base. And they have to be multiplying to be able to add our exponents. Okay, questions about that? Questions about that? Any questions about that? Okay. So now we have a group that one study team wrote the expression 10 to the third power times 5 to the fourth power equals 50 to the seventh power. Is their simplification correct? Did they do the right thing? Did they follow the process correctly? Look at what we just wrote on the last piece. Does 10 to the third power times 5 to the fourth power make 50 to the seventh power? Not according to what we just got done saying, right? So is their simplification correct? So let's do our sentence. Their simplification that's one of those weird words. And I still got it wrong. Even I know it's right there, but it's like, it's early morning. That's too long of a word. It's not correct because, okay, so why is it not correct? What did they do wrong? Why can't they make 10 to the third and 5 to the fourth into 50 to the seventh? Look at what we just said on part B and incorporate that and tell me why. The bases were different. Yeah, 10 and 5 are not the same base. This is what we're talking about by base. Base is the number that's carrying the exponent. So there's a 10 and there's a 5. Those are not the same. Since they're not the same, we cannot add their exponents. Okay, we cannot add their exponents. What we would have to do for this is solve the 10 to the third separately from the 5 to the fourth and then multiply when we're done. Okay, okay. Because the bases are not the same. So the exponents cannot be added, and you never multiply bases that have exponents. Okay, so we never do that 10 times 5. If it has an exponent, we have to remember PEMDAS. We have to do the exponent first. The PEMDAS would happen, the exponent would happen before the multiply. Okay, because the E comes before the M. So we can't do the multiply 10 times 5. Okay, cannot do 10 times 5. Okay, and we can't we can't add the exponents because the bases were not the same. All right, so that was a double thing that they did wrong there. Do we get it? Only add the exponents when the bases are the same. Do not multiply the bases until you handle the exponents. We never multiply the bases that have, there should be the word that, exponents because of PEMDAS. Exponent always comes before multiply. Okay? Do we get that? Are we okay on that? Let's look at what the next thing says. So, oh, look, they're going to have us do more of these in simplified form. These are easy. Write the expression in simplified form. Okay, so this is the way I want you to do this when we have these that are in problems like this. Step 1, pull all the numbers with each other. How many 3s do I see right here? How many 3s do we see right there? If I look at all the pieces, 4 of them. So that's going to be a 3 times a 3 times a 3 times a 3 times a 3. There's 4 of them, right? And they're going to multiply by. How many W's do we have altogether? The first one has 3. The second one has 2. And the last one has 1, right? Or the second to last one has 1. Do we all agree and understand where all those numbers came from and letters? Anybody not understand where those letters and numbers came from? Anybody not understand where I got all those letters and numbers from? Because I can color code them. See, here's the 3s. 1, 2, 3, 4, right? And then I got my W's, which I'm going to do in a different color. There's 3 there. That was the first 3 I put. Here's 2. So that was the next 2 I put. And then there's 1 more. It doesn't matter how many we're multiplying in a string, okay? We can have 7 or 8 expressions in a row, as long as there's multiply between and they're the same base. And we have to do this to it because we have to get the same bases together. All right? So pull it together. Tell me what the final answer would be in exponent form. Yep, 3 to the 4th W. Oops, got to get off. W to the 6th. Okay, so I want to see you spread it out and then pull it back together. Okay, questions about that? Not super tricky. Huh. What does that mean? We get to turn it in and start our homework, but I do want to make one change here. I want to add on something here. I noticed it says in exponent form at the top, simplified exponent form. So we are not going to multiply the 6. We're going to show these in exponents. 2 to the, how many 2's do we see? How many 2's do we see? 1. And 3 to the, How many 3s do we see? Also 1. So this is the simplified way you would write it because they wanted simplified exponent form. And then they might ask for a simplified final form, which would be the 2 times the 3 part. Okay, so as soon as you see one of them, the exponent in the sky is 1. Just like as soon as you see one letter, it's 1 times W or 1 times K or 1 times. Same thing with the exponents. As soon as I see one of it, there's a 1 in the sky. Okay, are we good? Anything we need to clarify? Okay, save it and turn it in. And let's go work on our homework. Maybe we can get our homework too. That would be super great. Okay. I forgot a question at the top. I did. Oh, thank you. It was okay. Let's go do this one first. Sorry. I know I told you that we were done, but we caught this one. This is an easy one though. Does 3 to the 5th power mean the 3 times 5? Does 3 to the 5th power the same as 3 times 5? Thank you, Charlie. Do those mean the same thing? 3 to the 5th power, 3 times 5? After what we've just got done with, 3 to the 5th power is the same as 3 times 5. No, because we learned, no. Remember, we're going to do this little trick of inserting an 3 to the 5th power does not equal, so I'm going to do equal sign. Oh, wait, I think there was a not equal in here. Yep, see right here, this is called not equal. Kind of nice. Yay. 3 times 5. And we're going to put it into the little, remember we did this earlier? I think this needs to be a 14, huh? And then we just go back to the no and put space bars to get past the equation part. Because what does 3 to the 5th power actually equal? So spread that one out. And we'll write that in our final answer. Thank you for catching this, Charlie. What would I write instead of 3 to the 5th power equals 3 times 5? 3 to the 5th power would equal 3 times 3 times 3 times 3. Oops, not that. I was pushing exponent and I wanted to push the multiply. Right? Do we agree? So I'll go back to this and I go space, 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 space. We didn't even have to make it complicated. Now save and turn in. And let's go look at our homework. Okay, save and turn in and open up your assignment, which starts here. I need everybody here, please. Turn in that assignment and get on to your Chapter 8, Assignment 1.